Hi, welcome to this presentation that is an overview of encryption inside of the Spectrum Protect family of products. In this presentation, I'll be covering the encryption features as of Spectrum Protect version 8.1.15 and Spectrum Protect Plus version 10.1.11. So encryption can occur in many different locations in the entire ecosystem of your production data, your backed up data, and the different copies you might be keeping of those backups. And so in this presentation, we're going to start by looking at the Spectrum Protect built-in encryption. That'll be the container storage pools with the server-side encryption, as well as the client-side encryption. We'll look at SSL for both communication and data transfer, and then finally Spectrum Protect server database backups. We'll then look at what happens with the encrypted data inside of Spectrum Protect when we move it between storage pools with things like replication, tiering, and retention set. We'll take a look at other types of encryption that include your device encryption and Aspera. And finally, we'll look at Spectrum Protect Plus encryption. So with that, let's first of all take a look at the Spectrum Protect encryption. So to start with, back in version 7.1.3 of Spectrum Protect, when we introduced our new container storage pools, one of the reasons we introduced that was so that we could have next generational deduplication, compression, and encryption. So both on the directory and the cloud container storage pools, we do support server-side encryption. And what server-side encryption does is it's going to encrypt the data after it's been deduped, after it's been compressed, but before it writes it out to the container storage pool or the cloud storage pools. So for directory container storage pool and on-premises cloud container storage pools, the default is no for encryption. But for your cloud storage pools off-premises, that is set to yes by default. Now, encryption is enabled at the storage pool level. And if you were setting up the storage pool with command line, when you did either a define or an update storage pool, you would set encrypt equals yes or encrypt equals no. Now, once encryption is enabled, all of the new data that's going to be stored in that container storage pool will be encrypted. However, this does not impact existing data already written out to that container storage pool. We also have an option called client-side encryption, and this was there prior to us introducing the container storage pools in version 7.1.3. And the difference between server encryption and client encryption is that server-side encryption is done at a storage pool level. Server encryption is at a chunk level. The Spectrum Protect server manages all of the encryption keys, and it uses AES 256-bit encryption at a minimum. Now, if you turn on encryption at the directory container storage pool level, that data can also be deduped, because remember, we dedupe, compress, and then encrypt it on the server. Now, if you were to use the previously existing client encryption, the client then controls the encryption at the object level, and that's based upon the include encryption or exclude encryption, as well as the encryption type options in the client options file. It is encrypted at the file level, and the client can optionally store the encryption keys in the tsm.pw file on the client. Now the options are AES 128 or AES 256. And it cannot detect any type of tampering and corruption when it goes to restore this. It doesn't have that built in place, whereas the server-side encryption does. Now, if you encrypt the data on the client using client-side encryption and then send it to the Spectrum Protect server, the server will not be able to dedupe that if it's being written out to a container storage pool. We'll talk a little bit more about client-side encryption in a few slides. If you want to set up server-side encryption in the operations center, if you go to storage pools, you'll see the ability to turn on encryption when you add a storage pool in. Now, one thing to note is that if you are encrypting at the Spectrum Protect server side, It will generate those keys, and those keys will be managed by the Spectrum Protect server. When we do a Spectrum Protect database backup of our metadata catalog, we do protect those encrypted keys. So it is critical that if you had some type of disaster on your Spectrum Protect server and lost your database and your storage pools, you would need to be able to restore your database, bring back those encryption keys so that you can then unencrypt the data that's been encrypted out in those container storage pools. If you lose the Spectrum Protect database, there's no way in heck that we're going to be able to unencrypt those container storage pools. Starting in version 8.1.2, we introduced the ability to encrypt directory container storage pools that had data that previously was not encrypted. Remember, if you turn on encryption for a directory container storage pool or any pool, it only encrypts the new data that's being written out there. So if you want to encrypt previously written data, you do need to run this encrypt storage pool command, and that'll go and encrypt previously backed up data. Okay, when you enable encryption for the Spectrum Protect server-side container storage pools, the encryption keys are going to be managed at a dedupe chunk level. And this is going to be a unique random encryption key that's going to be created for each chunk that's going to be used to encrypt that data. Now, in addition, there is a master encryption key for each chunk key. And this master encryption key is going to be automatically generated either when you upgrade to a version 7.13 server or when you install a new server instance that's at version 7.13 or above. The next couple of things I talk about are if you are at a version 7.13 to 8.1.1 server. And so in those cases, the master key is going to be stored in a dsmserve.pw file, and that's in the instant directory. And this is going to be encrypted, and it is going to be derived from the server password that you set when you issued the set server password. So it's critical that you have that server password. Otherwise, you're not going to be able to create the master encryption key. With those versions of Spectrum Protect server, you do have to make sure you're protecting that encryption key. The database backup command for your metadata catalog will optionally back up that master encryption key if it's version 7.13 to 8.1.1. And you should have issued this set DB recovery, protect keys equals yes, password equals, and then your server password in order to even enable encryption in the first place. Now, regardless of the version, encryption on the Spectrum Protect server does add additional time to the overall backup. That will be on the order of 1 to 2% of the total time that's required to do your backups. And you will also have some CPU impact as well if you do encryption. Now, in version 8.1.2, we added enhancements for a couple things. And one of those was the automatic generation of a master encryption key at the start of the Spectrum Protect server. This means you no longer are required to set the server password before generating a master encryption key. Also, what changed is now we're storing the key's password in a stash file called dsmkeydb.sth. Remember, previously it was stored in the dsmserver.pwd file. This is password protected using a random password, and the owner permissions of both the key databases and stash files are only for that instant user of that server. In addition to our master encryption key enhancements in version 8.1.2, we also changed the way that we use SSL. We started requiring certificates that enforced the use of SSL between communications of the Spectrum Protect server and clients. And these are being stored in our cert KDB and being accessed by our stash file cert.sth. And we'll talk some more about those server SSL for our communications in a few slides here. You do need to still protect those key databases, the cert KDB and the dsmkeydb.kdb, as well as the stash files. And by default, your Spectrum Protect backup database command will protect that master encryption key However, you still have to remember the database backup password in order to be able to restore that database in order to be able to access those encrypted files. Okay, with that, let's go ahead and take a look at client-side encryption and API encryption. So encryption on the client side or via the API, that's going to be the last step before the client or API sends data to the Spectrum Protect server. It does support AES 256 and 128-bit encryption, and there is some simple key management that creates and stores the key in the Spectrum Protect database. Now that registered key management is with the backup archive client encryption, and it's going to work with both legacy storage pools as well as your container storage pools that support the dedupe. Just remember that if you do encryption on the client side, dedupe will not work. You will not get any deduplication done on that, but you can still store it in the container storage pools. So in order to enable client-side encryption in the DSM opt or DSM sys file on the client side, you do need to do these include.encrypt and exclude.encrypt options, and then choose an encryption type of either AES 128 or AES 256. And then you can choose what you want to do with the encryption key. You can either have it save, which will save the encryption key to the backup archive client password file called tsm.pwd, or you can have it prompt, and that will prompt the end user to manually enter that. And then if this is an API call, you can also say that you want it generated. Now remember that if you encrypt things on the client side, the server does not know about that encryption. It cannot work with that encryption. So if you try and do things like send it to a dedupe pool, we can't dedupe it. So it'll be stored undeduped in that container storage pool. Also, if you encrypt on the client side, compression will also not work on the server side. So you are kind of limiting your options if you do turn on client-side encryption. With the Spectrum Protect 4 family for both the TDPs, Spectrum Protect for VE and HSM, for Spectrum Protect for VE, SSL is supported and the server container pool encryption is supported. So if you're backing up your Spectrum Protect for VE or any of these TDPs to the Spectrum Protect container storage pools, they will be eligible for dedupe, compression, and optionally encryption. Client-side encryption for incremental forevers is not supported for your Spectrum Protect for VE. When we looked at Spectrum Protect for databases, mail, or SAP HANA, then the API or client-side encryption is supported, as well as your server-side encryption. It does support SSL, and that SSL would be if you wanted to encrypt the data as it was being sent across the network. Remember, for communications in version 8.1 and above, that's automatically encrypted with SSL. There is also encryption that's provided by the databases themselves, like SQL, Exchange, DB2, Oracle, and SAP HANA. And all the databases provide an encryption capability for that data stored within the database. So when the TDP client backs it up, it is backing up encrypted data. So this might be one reason you don't want to turn on client-side encryption. For space management, Spectrum Protect for space management for the Unix HSM pieces, it uses the same mechanism as your backup archive client. So either you can specify that on the client side, or you can just use your normal container storage pool dedupe. If you're using Spectrum Protect HSM for Windows, then you would use the Protect API options to do encryption. With Spectrum Protect for ERP, we do have encryption using the SSL connections. So SAP HANA supports encrypted SSL and unencrypted connections by default. So for Spectrum Protect for HANA 8.1.9, we do support this HANA encryption. And so if the HANA global.ini section in the communication parameter of SSLE enforce, if that's set to true, then only SSL connections are possible. Okay, as I mentioned, in version 8.1.2 or 7.1.7, we made a lot of security enhancements, and one of those was to implement secure communications using SSL. So now, whenever the Spectrum Protect server talks to, for instance, the clients or different agents, we utilize a secure certificate to make sure that who we're talking to is really who we should be talking to. And so these self-signed or CA-signed certificates will be passed from the Spectrum Protect server out to the clients and the agents to enable this SSL. Now, this SSL is by default only for secure communications. If you wanted to also use SSL for encrypting the data, when the data is passing between the clients and the server, we do have an option where in the client DSM opt or DSM sys file, you can set SSL equals yes. And so in versions prior to 8.1.2 or 7.1.7, this would be for both the communication and the data. But in versions after 8.1.2 and 7.1.7, when we're already utilizing SSL by default for communication, this SSL equals yes is for the data transmission. Another place that you can utilize encryption is with the Spectrum Protect DB2 backup. Remember, our DB2 is our metadata catalog, and DB2 actually has native encryption built in, and it does require a password to unencrypt that DB2 backup. But we do allow you to use that DB2 encryption when you're doing your Spectrum Protect database backup. And that encryption can also be used if you're sending your Spectrum Protect database backup out, for instance, to the cloud. Another nice thing about when we send our Spectrum Protect database backups out to the cloud is we will also send those key files that I talked about, as well as our dev config files and volhist files out as well, so that everything will be present if you did have to do a disaster recovery of your Spectrum Protect server. Okay, now that we've talked about how Spectrum Protect can do encryption, remember we can encrypt on the Spectrum Protect server side with our container storage pools. We can encrypt on the client side with our built-in client encryption. We automatically encrypt communications between the client and server using SSL, and we provide encryption for our Spectrum Protect database backup. Now we're going to look at how does encryption of that data work when you're moving that data between our different storage pools. The first thing to note is how encryption works with replication. So by default, we're pretty lazy. If we've already encrypted the data, we're going to keep it encrypted regardless of what the target replication server has set for its encryption. If you do not have data encrypted on the source server, but your target server requires it, we will encrypt it in transit so that as it crosses the network over to the target server, it will be encrypted and land on the target server encrypted. If it is going to a legacy server that doesn't have encryption, then of course we will unencrypt it so that the legacy server can understand it. This is going to be the same when we do tiering out to a cloud. So if you have a directory container storage pool and you've set up tiering, depending upon the encryption, once again, we're lazy. If it's encrypted, we leave it encrypted. If it's not encrypted on the source pool and the target pool requires it encrypted, we will encrypt it during tiering. If your directory container storage pool is encrypted and you are creating a copy of that directory container storage pool out to either tape or VTL, we will unencrypt, uncompress, and undedupe the data prior to writing it out to the tape. And the reason for this is we want the data on the tape to be able to be restored directly from the Spectrum Protect clients. And the tape storage pools use a different type of encryption, and I'll talk about that in a bit. Now, if that encryption came from the client side, then we do not unencrypt it prior to writing it out to tape. This is only server-side encryption that we're unencrypting when we do a copy container of a directory container out to tape or VTL. The same is true when we tier to tape. Once again, when we tier to tape, we also unencrypt, uncompress, and rehydrate that data, and we will thus unencrypt server side. However, we will not touch client side encryption. If you have created a retention set and you want to copy that retention set out to cloud, if any of the data in the retention set was encrypted using server-side encryption, We will first rehydrate that data. That means we will unencrypt it, we will decompress it, and we will reassemble all of the extents to form a completely rehydrated file. We'll then take that file and chop it up into blocks, and we're going to send each block out to the cloud. And at that point, you could choose to encrypt it before it's sent out to the cloud. So the encryption is at block level, and this is going to allow the subsequent retrievals from anywhere within the volume and not having to worry about those individual dedupe chunks being encrypted and scattered all across the cloud. Also, remember that when we copy retention sets out to cloud, we do use a different location. We do not use the same location as we're writing backups out, and that is because we are rehydrating the files. The same goes for when we copy a retention set out to tape. We will completely rehydrate, uncompress, and unencrypt the data on the fly as it's being copied out to the tape, so that when the retention set hits the tape, it is fully hydrated and can be read directly by the clients. Okay, now let's look at other types of encryption that might be present in your IT environment and how Spectrum Protect works with those encryptions. So first of all, a lot of tape drives and VTLs do encryption on their own, and most of that is basically going to be invisible to Spectrum Protect. When we utilize those devices to store our backups on, we simply pass the data to them, and it's possible they'll encrypt it and unencrypt it as it's read to or from Spectrum Protect. That said, there is an application managed encryption for tapes called AME, and this key management works with the Spectrum Protect application and some specific libraries and devices. So with the IBM 3592 Generation 2 and beyond, with the IBM Linear Tape Generation 4 and beyond, and with some storage tech drives, you're able to turn on this AME encryption, and that's done when you define the device class. You can add this drive encryption equals, and then either on, allow, external, or off. And depending on what you set it to, either Spectrum Protect will manage the keys, if drive encryption is set to on. Allow means that Spectrum Protect does not manage the keys, somebody else is managing them, but we're still using that drive encryption. External is also managed by someone besides Spectrum Protect, but we're still utilizing tape encryption. And finally, off means that we are not doing drive encryption on those specific devices. Now, other hardware or operating system disks do encryption, and that might be disks that Spectrum Protect databases, logs, or storage pools reside on. And all of this is, in essence, transparent to Spectrum Protect. That type of encryption is being handled by the device or the operating system. Now, there might be overhead for the I/O, the reads and the writes that are done on these types of devices, but that's going to be a performance question you'll have to look at. When it comes to something like VTL encryption, when we store our data on VTL devices, the encryption is going to be outboard from the Spectrum Protect server, and it's once again transparent to us. So sometimes this is suitable and works great, but you do have to look at how it scales and what would happen if there is a disaster pulling that data off of the VTL. Are the keys available to that VTL to make sure that Spectrum Protect can still do the restores? Now, when we go to back up files that are sitting out on different operating systems, many of those operating systems or devices will encrypt the files themselves. And so if the files are backed up in a raw encrypted format, most likely they won't be able to be deduped. We simply won't get any dedupe hits on that. When we think about raw data, we're basically looking at data that was previously encrypted by somebody else, maybe the operating system, maybe whomever. So if it's not raw data, usually Spectrum Protect is able to get a pretty good dedupe ratio on it, and you will have deduped entities out there that we can manage. Now, if it is AIX JFS2 encrypted file system, there is an option in Spectrum Protect called EFS Decrypt, and that is set in the dsm.opt file. And that allows you to backup files either in clear text or the raw encrypted format. And with the raw format, which will be your default, the data will not be decrypted before it's sent to Spectrum Protect to be backed up. If you set this to clear text format, then the file is going to be decrypted by EFS as it's being read by the Spectrum Protect to do its backup. And so this is useful if you want to use the Spectrum Protect deduplication and encryption that's built into our server, or you want to use some other type of hardware encryption on your backups. Another reason you might want to unencrypt it is if you're going to be storing that data for long-term archive or long-term retention in Spectrum Protect, you probably want that in clear format. You don't want to have to worry about accessing keys to be able to unencrypt it once it's been restored back to your operating system. Another niche solution that's offered with Spectrum Protect starting at version 7.1.6 is our WAN optimization with Aspera FASP. And what WAN optimization does is it helps with node replication and protects storage pools for Linux Spectrum Protect servers. And it really works well if you need to optimize your server-to-server replication data transfer. And this is usually because you have a network that is impaired or losing a lot of packets. FASP will use SSL and Aspera AES 128 encryption during the transfer. And this is regardless of what SSL or encryption is enabled on the Spectrum Protect servers. When you're looking at if Aspera will help you, it's usually for impaired networks where your latency is greater than 50 milliseconds and your packet loss is greater than or equal to 0.5%. So remember, this is for Spectrum Protect servers on Linux version 7.1.6 or later, and for replication of your directory container storage pools between those two Spectrum Protect Linux servers. And it is a separate license. However, the code is part of the Spectrum Protect server download. So I've spoken about the Spectrum Protect environment, both our server-side, client-side encryption, as well as our SSL and DB2 backup encryption. We looked at the way that encryption impacts data movement between our storage pools, and we looked at other types of encryption, both device and Aspera. Now we're going to switch gears and look at where inside of Spectrum Protect Plus encryption plays a role. The first piece is with our OpenSnap Store Manager, which is that common data repository between your Spectrum Protect Plus and your Spectrum Protect server. So basically your Spectrum Protect Plus can back up directly to a Spectrum Protect container storage pool. And this means that the Spectrum Protect Plus backups can take advantage of the dedupe, compression, and encryption that resides on directory container storage pools. The next area you'll see is that your Spectrum Protect Plus VSnaps. Remember, VSnaps are like storage pools for Spectrum Protect Plus. Those do utilize default self-signed TLS when they're communicating between the Spectrum Protect Plus servers and the Spectrum Protect Plus VSnaps. So this secure communication was introduced in version 10.1.11 of the Spectrum Protect Plus. And with that 10.1.11 version, each VSnap server will have its unique self-signed TLS certificate that's based on hostname IP address. And that certificate will be strictly validated by Spectrum Protect Plus. Now, the VSnap itself, you can also turn on encryption for that VSnap and encrypt the data that we store out on that VSnap. This encryption is at rest. It is AES 256-bit. And when you initialize the VSnap server, that is when you would turn on encryption. Once it's turned on, you cannot turn it off. And a key file is going to be auto-generated when that storage pool is created. And then all your disks in a VSnap pool will use that same key file for encryption. So at the time of installation, you can do this vsnap system init, and then you would do -- encryption space on. When you add new disk to a VSnap pool, IBM Spectrum Protect Plus will check if that pool contains encrypted disks, and then it'll encrypt the new disks using that same key file that it used for the existing disks. Now, VSnap copies can optionally use encryption at rest on the replication targets. So if you do have that VSnap replicating out to another target, you can turn on encryption at that other target. During replication, that data will be unencrypted, transmitted, and then re-encrypted on the destination target. With Spectrum Protect Plus, we do support Oracle multi-threaded log backups. It is encrypted using AES 128, and that is a randomly generated key. The keys and other configurations are protected using file system privileges, and only the SPP agent OS has read privileges for those. Now, you do use a separate key for each app server, and that's going to ensure that if one is compromised, then the others won't be compromised. If you are using our BAS agent to back up Kubernetes or OpenShift environments, we do allow a encryption as part of our service level agreement for those PVC backups, and that is simply part of the SLA when you're setting up the OpenShift or Kubernetes backups. Another place you'll see that in Kubernetes is we do have a security certificates in Kubernetes managed by the Kubernetes Certificate Manager. And this allows for TLS to encrypt the communication between the pods in the Kubernetes cluster itself. It does require that you install the Certificate Manager package from JetStack. And once you've installed that Cert Manager, it will create, distribute, and as time goes by, expire off those self-signed certificates. If you're using Spectrum Protect Plus and backing directly up to an object store, instead of backing up to a VSnap, the backups on the object store are going to be encrypted by default. We figure those object stores are probably public clouds, so it's probably best to have the backups be encrypted. And the encryption password is stored as an attribute of the SLA policy. Okay, with that, I've gone over all the different encryption pieces inside of Spectrum Protect and Spectrum Protect Plus. Thanks so much.